Okay, so hopefully that is the last of that. Sorry for the technical difficulties here. So this is 212. I'm Ted Pavlik. And so mainly today, just want to go over a couple of the course policies and then briefly kind of introduce the course. This is a really weird room. This is normally when I teach this in this building, it's downstairs where the computers are facing the wall. So a little strange, the kind of perpendicular thing, but people will probably just get used to it. So this is a course about dynamics, about dynamic processes. So this used to be called like Calculus 2 for sustainability, but to change kind of the focus of the course. So when you've all taken a Calculus 1 course, either in sustainability or for those of you who aren't sustainability majors outside of sustainability, you've learned a little bit about differentiation, about integration, things like that. And those are the mathematics that help describe how things change over time. In this course, we are trying to make it so that we can take the principles that you've learned in those courses, and instead of having to write out all of the math, we just write out basic relationships between some of the entities that really come out to just basic arithmetic. And then we enter that into a computer, which effectively builds these equations for us and ends up doing the integration for us. So whereas in a Calculus 1 course, you'd start with sort of the equation and you figure out how to find a solution, this course is a lot more about building the equations and using a computer to find that solution. And so we, in this course, are going to be using a lot of systems thinking. So how many people have taken SOS 220? So you'll see a lot of overlap with 220. 220 is a systems thinking course, whereas 220 doesn't go into as many of the quantitative schools, does focus on things like feedback loops and so on. So that's what we're going to really be focusing on this course is, given known sets of interdependencies among variables in sustainability problems, then can we use our knowledge about those to build simple expressions, not complicated kind of calculus expressions, but simple expressions that capture those interdependencies, and then allow a computer to unroll them so that we can see, given these amount of interdependencies in a system, can we make quantitative predictions about how that system might behave over time. So that's kind of what we're doing here, is using the computer-based tool to do the math for us. That's what really this course is all about. So we changed the name to System Dynamics and Sustainability. It's not really a calculus course. It's a course about learning how to take dynamics and build them into these systems. So there's a nice example from Jean Bellinger here, sort of scared to try this in this classroom, but let me see if I can manage to get this working. I figure out which side. Good, okay, it's that side. So like if you were to, all these slides that are now, and I'll talk about the course organization stuff. And so all of these slides are available on the Canvas page. Just before class, I published the Canvas page. This is, and I'll mention this a little bit later too, maybe, but this is, like I said, the first time I taught this course in the fall. I normally teach it in the spring. And so it turns out that for one thing, there's one less lecture in the spring, one less lecture in the fall. Fall starts on a Thursday, spring starts on a Tuesday. So it's been kind of a headache getting the assignments to line back up. And that's why I took a while to publish the Canvas page. And I'm still working on realigning some of the assignments. And some of the assignments aren't published yet, but most of the main content is there on Canvas and all of the lectures are on Canvas. So so this will be up there as well, and you can click on that link if you'd like, if you'd like to run through this example. But this is kind of an example of a predator-prey system that's modeled in this tool called Insight Maker. So we're going to mainly, the two big tools that we'll be introducing this semester are a tool called BinSim. It's a tool that is going to be available on all of these computers. You can also download it for yourself. It works for both Mac and for Windows. It's a tool that's used in industry. And then there's this Insight Maker, which mimics a tool used in industry called Stella, but is meant to be kind of an educational tool. and it runs completely in a web browser. So you can create a free account in Insight Maker, and then you can go and build these models and simulate them all within a web browser. And they both do very similar things. The only reason I teach both of them is some students like one better than the other. Some students have more technical challenges with one than another. If you end up liking one, you can kind of forget about the other one. So none of the exams that I'm going to give here or any of the things we're going to be talking about specifics of one or the other. They'll talk about generic things that could be answered with either. But I want to make sure you have a tool that you're comfortable with. So we have both of these. So this is Insight Maker. And so this is kind of an example that, again, so that that Bellinger has kind of a canned example of what the sort of things that we will end up doing in this class. And so the idea here, and I'm just going to sort of narrate this myself, is if you were wondering about trying to explain the dynamics of a predator-prey system, like this moose and wolf system. And so you have to say, well, there's a lot of things going on there. For one, we know that there's probably some growth process going on with both the moose and the wolf. And so if I just build a moose model here, then we're going to learn how to build these models. So I'm not expecting you to already know how to read these things. But basically, if you were to think back to calculus, anything that is a box is like a variable. And when it has a line going into it, that suggests a differential equation with respect to that variable in time. So this is basically saying that if you remember back to ASU 101 or for a calculus class, this is sort of saying that d moose dt is equal to some birth rate times the number of moose minus some death rate times the number of moose. So we'll eventually learn how to read these things, but we're just showing graphically what we used to write in an equation form. And so this, we know very simply that there is some birth rate. So every moose, for every moose, it produces on average maybe one offspring per year or whatever. We put that as a birth rate. We also know that moose live for an average of so many years. We can do 1 over that, and that gives us the death rate. And we have just a simple model for a moose population. And we can put that into a tool like this. And if you were to do that, you can simulate it, and you end up getting curves that look like this. So if you can't see these things, basically these are, the blue line here is the number of moose populations, the orange is the number of moose births, and the green are the number of moose deaths. And so, not really that surprising, this looks like an exponential growth curve. It's so basically saying that if all you have in a population is moose, and there's nothing limiting their growth, then they grow to the sky. They grow forever. So that's not, that doesn't really capture reality there. So we might then say, well, what more can we do to complexify this model? Well, we need a wolf population too. So we can put a wolf population in here, same sort of idea. This is the number of wolves, d wolves dt, it's got a wolf birth rate, wolf death rate. And with those sort of things, we can also simulate a wolf population that in this case, because the death rate is higher than the birth rate, you start out with an initial number of wolves, that's this green line, and it decays asymptotically to 0. So these curves, if we were to write the mathematical equivalent of that diagram, you could, using stuff you learned in Count 1, solve for something that if you plotted it, would be this green line. We didn't have to do that. We had to sort of write it in, hit go, and it plots it for us. And that's kind of what we're seeing here. So we're seeing now that we've got, if you leave moose alone, they grow to the sky. If you leave wolves alone, they plummet into the ground. And so neither of those seem very realistic. And so the kind of systems thinking idea is, well, what if I move forward and I start coupling these things together? And now I see that when there's a lot of moose, basically I'm going to have that have an impact on the birth rates. In other words, if there's a bunch of food around, then wolves will be able to have more wolf babies. And then likewise, there's going to be a coupling into the death rate of the moose from the wolves. And so we'll learn how to write the math behind this all, but this basically, this kind of almost a systems diagram, like you learned in 220, links these two together where it'll say if you have more wolves, you're going to have a higher death rate of moose. So now we've created a feedback system. We have these two systems that independently would grow to the sky or plummet to the ground. And if we were to then simulate these two coupled systems together, then we get some interesting dynamics that maybe were not things that we anticipated ahead of time. So now we're seeing the green line as wolves, the blue line as moose. The rest of these lines are their birth rates and death rates. If I just focus on the populations here, then we see that there's this kind of oscillating characteristic where one is leading the other one. So if as I get a peak in wolves, well, if I get a peak in moose, a little bit later, I get a peak in wolves. But as the wolves start growing, the moose start dying. And as I get fewer moose, then eventually I get a trough in wolves. And these things kind of go back and forth. And so this, I'm not saying, is necessarily the most realistic trajectory for a predator-prey population, but this, in theory, is a non-trivial trajectory you could get out of predator-prey as they kind of go back and forth. And it turns out that there are a few systems that you can find in nature that do have this oscillation. So you go into a particular lake in Africa, for example, and you sample the number of fish. And sometimes you have a huge number of one fish and not many of the other. And then in other times, it's the reverse. And if you keep coming back, you keep switching back and forth. And without this theoretical lens, then we don't really have a way to make sense of that. But seeing that if you couple these things together, it can generate these sorts of oscillations, helps us generate new hypotheses that we then can test in the real system. So that's kind of what we're trying to do in this class, is get us to the point where we can build these hypothetical models. So that's my kind of wolf and moose example. So let me just head back to here. And so, there's also other sorts of examples. It's kind of more like 220, where this is kind of this cute example with the bird feeder. And for those of you who've taken 220, then you've probably seen plenty of examples that look like this. But this is kind of a nice, for those who haven't taken a systems thinking course, this is, I think, a nice example where it's going to be hard to read here. And so I'll just kind of illustrate that there's a little box up here that says birds outside of breakfast creates a pleasant morning. So this is something that we know individually, this is always true. This is generally true. If I see birds outside for this type of person, it makes their morning more pleasant. So that's a simple thing that we don't have to challenge. But we then also notice that if I have a pleasant morning, that encourages me to make a bird feeder. So because, I think, oh, this is kind of fun looking at these birds, I'm going to put a bird feeder out there. So that if I keep going down this path, then I see that if I put a bird feeder out there, that's going to increase the birds at feeder, which my intended outlook would be to improve my pleasant morning, this thing here. So I'm starting to see a positive feedback cycle, like on growth, like the moose growth there. Now, the thing is, if you keep doing this, then it also does, it increases the attractiveness of the garden, which might also has a positive feedback. The attractiveness of the garden might even attract even more birds. So all good after that. But the thing is, and then it also detracts, a pleasant morning reduces frustration. And if you reduce frustration, that's going to further increase the pleasant morning. So again, this looks like it's a more and more complicated tale of all good things. But if I keep going here, then I find that the number of birds at feeder increases the needs to buy bird seed. And with increased need to buy bird seed, I have increased frustration. So now the same thing that over here was looking like it was all good, apparently has something putting it in check, where eventually the need to buy bird seed might take away from the pleasant morning. On top of that, it increases spillage, which increases the need to buy that seed, but also spillage is going to attract squirrels. And those squirrels are going to chase away the birds, which is going to decrease the feeder and so on and so forth. And so you keep going down here, and what we see is taking a systems perspective allows us to assemble tiny relationships that are incontrovertible. Like we know that seeing more birds in the feeder is going to make you happier, or make this person happier. And so if we take a narrow view, then it might suggest one course of action. Get a bird feeder, buy a dog, buy a cat, have children, all of these sorts of things that seem like, an immediate way to increase the joy in your life. But when you zoom out a little bit, you find out that there's all these side effects. And that taking this systems perspective means that the optimal choice is probably somewhere in between the two crazy alternatives you have of maybe no bird feeder and bird feeder, or whatever it may be. And so in order for us to make informed decisions, we need to zoom out. And the tools that we'll use in this class build on, this is basically SOS 220. SOS 220 is all about if I take these little individual links and put them together, what sort of feedbacks might be there. Then we're taking this and we then turn it into the diagram like I showed you on the previous one, where we can actually animate it over time. And so not only do we recognize that there are feedbacks there, but you can use quantitative predictions to help us figure out what the right solution might be. And if, let's say, temperature changes through climate change or whatever, how that right solution might shift in a quantitative way with the changes in the environment. So those are things that we sort of learn how to do in this class. All right, so any questions about those two examples? That's the clear motivation for what we're trying to do. And coming into this class, I'm not expecting, you won't be solving, again, much calculus. You want to occasionally be able to recognize a differential equation, but you won't have to solve one. I'm not expecting you to have any background in computational modeling or simulation or tools. That's what you learn in this class. So a little bit of arithmetic, a little bit of willingness to look at some graphs and think about graphs critically, and then otherwise we'll learn the rest in this class. So it's my claim that, so if you look at our School of Sustainability website, there are these things called core sustainability competencies. And there's 5 of them: system thinking, future thinking, value thinking, strategic thinking, and collaborative competency. And these are the ways in which somebody asks, what is sustainability? Well, the experts say that if we want to come up with a real objective definition of what sustainability is, we can break it down into these 5 things. So a sustainability scientist is equipped with tools that allow that scientist to work along these dimensions. And it's my claim that in this class, with the modeling tools that we picked up, that we hit 4 out of 5. So we're going to be thinking about systems, kind of already motivated. We're going to be thinking about making, trying to incorporate future outcomes into current decisions. We're going to think about strategies for making future outcomes kind of come true. And then this collaborative competency, what a lot of people don't realize here, but I hope that you can start seeing this, going from differential equations to computer simulations is actually really improves your ability to communicate. Being able to show someone a graph, being able to walk someone through a narrative is going to help you make an argument far better than showing them some equations. And that's another skill that we're going to be trying to use here. And then on top of that, when you work in groups together, having a tangible transitional object, a boundary object that allows everyone to sort of interact with it makes it much easier to pour your ideas into and have them being properly interpreted by someone else, and then have you get that feedback from someone else without having to worry about the ambiguity of words. So the quantitative tools we have here are not only meant to help us make predictions, but are also meant to make us better communicators of sustainability problems. All right, so any questions? All right, so this gives me an opportunity to introduce these things. So when I have these classroom things, I will periodically have these slides pop up. Now, I'll mention about modalities here in a second, but basically, if you ever have a question and you don't want to attach your name or your identity to it, you're free either here in class or with your cell phone or whatever to go to this URL or to go to that QR code and submit an anonymous question. And I will, when I'm not as frazzled as I was coming in here today, try to monitor them during class. If I don't get to your question during class, then I'll try to answer it on Canvas or on Slack after class once I see it. So it's an opportunity to ask these sort of anonymous questions. And I'll also mention here in a second that that I do support in this class kind of a sync modality. So now the Canvas's page is up. If you would like to participate in the class remotely or asynchronously, then there are options for that. And this still allows you to interact with me. Of course, if you're linking in synchronously, there are other ways you can get my attention through the Zoom chat, things like that. But if you're still want to be anonymous, or if you're asynchronous and just want to put a question in the queue that you don't want to maybe post on the discussion boards, then this is the way to do it. Okay.
So I have a question.
Yeah.
Why is 4 out of 5?
Well, so the last one here, values thinking, is an important competency, but I don't think that in this course, the scope of this 200 level modeling course, we really get into that kind of the values components. There will be opportunities for that. There's a project in this course, and so I think that your students will have an opportunity to couple that in. But generally speaking, the content of this course really sticks more to the modeling and less to maybe, you know, like how modeling might affect different groups differently, or how different groups might use modeling. So it's just not kind of a core feature of the course, but I definitely think more advanced uses of modeling could start to blend it. Does that answer your question? Is that plausible?
No, it makes sense. But ultimately, it sounds like it's just a complex cost values in as elements of the simulation.
Right. Well, I mean, this is originally in Calc 2 for sustainability. And so it's a 200 level course. So a lot of students, because it's not a prereq for other courses, take it late in the career, but it's designed for potentially, you know, the second year students in sustainability. And we're sort of building from basic foundations, just trying to build up to the kind of quantitative tools. And we kind of run out of runway sort of to do everything. But I do think there are sort of like 500 level courses, for example, that we do in dynamical systems modeling that really, I think, can get into coupling in how to complement thinking about the subjective aspects of society with these quantitative aspects too. So I think that's there. I don't want to say this can't be, quantitative modeling can't contribute to all 5, but this course is a limited scope. Okay, great question. Any other questions? Okay, great. All right, so administrative stuff. So Canvas is now published here. So this is a screenshot from spring 2021. So, but it's basically a similar layout. So the way on the home page of Canvas here, if again you're interested in attending remotely, there's a direct link to the Zoom that can get you in live, as well as a link to the recorded classroom recordings from the semester if you want to watch asynchronously. So synchronous, asynchronous. And the office hours information are here. And so I'll be posting Zoom office hours. My office is way over in the Brickyard, which is sort of probably far from most of you. And so I've just been making use of the Zoom office hours, and usually it helps people share a screen and things like that. But if for some reason you do need to meet in person, we can make that happen as well. The TA is back in the corner. And so he will also have some office hours available. He'll be doing a lot of the grading as well. So if you have questions about grades and things like that, then his contact info will be up on this page here. He's just got access to the site just as you guys did. So I haven't had a chance to update that just yet. So so those are 2 ways to contact with us. There are a number of different other ways to connect with each other and to connect with us. So like I said, there's discussions, there's Slack. You can feel free to direct message me. A lot of students feel like to do that instead of email. That's totally fine. I've got this people link here where you can find others that are in the class, which will be useful when we start talking about final projects. So feel free to make use of those tools. Now, the big thing, most of what you'll find in Canvas for this course is going to be under modules. You can find it other ways, but I've tried to organize it so you can kind of live inside modules. And because there's so much there, what I recommend you do is when you go into Canvas to hit in modules, hit this collapse all, just smash that button first to collapse all of these individual modules down into this here, because again, when they're all expanded, it just looks like a lot. But the way they're organized is up at the top, we've got this module here. If you expand that down, that's where you can find the syllabus. You can find information about how to get to the software we've talked about, VinSim and so on. You can find Insight Maker as well. You can find a tentative schedule for classroom activities and so on and so forth. If you want to get access to the asynchronous recordings from this semester and previous semesters, you can go into this classroom recordings module. And then the thing that we'll have to worry about, kind of the most immediate thing here, is there is kind of a syllabus quiz that is built into this Unit 0 module. So if you open that Unit 0 module, you'll find there's basically one thing in there, and that's this kind of syllabus quiz. You have to complete that to get access to all the other modules in the course. So that is, I think, due this Sunday, but you can complete it as many times as you want. You have to get a perfect score on it. If you happen to do it a little bit late, I'm not going to take any points off for it. But I just putting it in there as a goal to have it done by Sunday. And it's just a syllabus quiz, and once you've done that, it'll open up all the rest of these things. So the way the rest of this is organized is basically I've had some students like to have all the assignment types in one place. Other students like to have things sort of interdigitated in a kind of chronological order. So I've done both of those things. And so some of you will hang out at the top of the modules and some of you will hang out at the bottom of the module. So up here at the top, the sort of four major assignment groups here, which I'll talk about here in a second, muddiest points, readings, homework assignments, and the final project have all been clustered together by that assignment type. So you can find them all out here, but they also will be peppered in down here. So at the bottom of the module, I've got all of the units. So Unit A, Introduction to Simulation. Unit B, Causal Diagrams. If you expand those out, you'll find that it'll have lectures, homeworks, etc., all sort of in chronological order, the way they're presented. So if you like to think kind of sequentially through the course, down here, if you'd rather think in terms of what type, like I need to get to the next homework assignment, up here. So it looks like a lot, but again, I just encourage you to hit that collapse button first, and then hopefully this will end up being relatively easy to navigate after that. Like I said, some of these assignments I still am working on moving around to get them lined up with the spring schedule. So like if you go into, I think probably the homework assignments, it won't look like anything's published right now, but hopefully tonight or tomorrow, I'll have all that worked out so that all these will be populated, and you can even start working on them ahead of time if you'd like. They're all going to have due dates, and so the Canvas calendar, as well as the course summary at the bottom of the home page, you click on home and down the very bottom of it, all should be ordered up by those due dates. And so you want to know what's due next, you can trust Canvas, those due dates should be in there, at least after I get things all sorted out again after this shift from fall to spring or spring to fall. All right, so any questions about this organization here? Pretty simple some stuff. Do you have any trouble finding anything? And everything should be on Canvas. But just let me know. Feel free to contact me however you like. If you do need to email me, speaking of contact, so then you get a lot of like other email about people wanting to sell me stuff for my lab and things like that. So I highly encourage you to put SOS 212 in the subject, just so your email can get flagged and so I can get back to you as soon as possible and it doesn't get missed or put into spam or whatever. Or like I said, you can contact me with one of the other modalities, Slack, etc. If you do have a question about graded work, then I encourage you to, because Jorge will be doing the things that aren't auto-graded, except for one or two maybe exceptions, will largely be graded by Jorge. And so I would encourage you to either email him first or email both of us. Because if you email me, I will need to check with him. So I'm just going to forward to him and get sort of background info. And so so with that in mind, if we're looking to streamline things, is that if you have a question about graded work that wasn't auto-graded, then email Jorge or email both of us. If you have questions on something that's auto-graded, then that's probably my fault if something screwed up. So you can email me directly. All right. Questions about that? Okay. So office hours, syllabus, all the course info things. So if you're open that course policies up here, this is sort of a sample of what you'll see. There's stuff about how do I use Canvas for different things. There's simulation resources. If you're interested in doing an honors contract in this course, There's the honors contact information, so take a look at that before reaching out, and so on. So all of that's kind of there. Oh, and then course textbook. There is a textbook associated with this course. If you want a hard copy, that's great, that's fine. But this textbook is available 100% for free from the library. I've got an online link to that from our ASU library. But I've also gone ahead, and I'm probably not supposed to do this, but downloaded the PDF of it ahead of time and just made it available from here, so you don't have to go chapter by chapter through the library interface. So if you don't want to buy the book, it's fine, it's all there. If you want a hard copy, that's great too. It's totally up to you. So book is available there on Canvas, on his contracts. I just like to point this out, it's a lot of students, I think they'll know about it, but if how many people have used the what if grades in Canvas? So a couple of you. So a lot of times students, you're getting towards the end of the class, they're looking at the grades, and they might be kind of curious about what sort of grades they might want to hit on certain assignments, or given they know that some assignments are dropped or whatever, maybe there's certain assignments they don't want to turn in. If you go to the grade book in Canvas, you can actually click on grades that haven't been submitted and submit a hypothetical grade, and it will recalculate your grade as if you had scored that. So these what if grades are available there. And the weird thing about Canvas is instructors don't have access to that. So if you email me and say, hey, what do I need to get on the final to get, an A- or something like that? The only way I have to do that is actually go in the grade book and give you fake grades. And I like to avoid that because it pollutes all the grade history. But you have access to go in here and you can do that game yourself without even having to get me in the loop. So if you've never used that before and want more info, I've got a link to it. And then, like I said, we use Vinsim and Insight Maker. So if you're interested in downloading Vinsim yourself, it works on both Mac and the Windows. There's a page there that tells you how to do that. Insight Maker is you just have to set up a free account on a website, and there's a page here that tells you how to do that. I've also put together a lot of tutorial videos for both of these software packages that go beyond what we talked about in the class here. One of them, I'm sort of surprised, like some of the Vinsim videos here got 20,000 views since it recorded them a couple of semesters ago. So for whatever reason, they get a lot of attention on YouTube. And so so if you're having trouble with Vinsim or want to do something more advanced, take a look at those tutorials. Maybe they'll help. Well, of course, you can email me and ask. So then this is what the readings look like. So readings here. So we'll see that when there are certain lectures, like lecture A3, this is lecture A1. Tuesday will be A2. Thursday will be A3. And so before certain lectures, there's an expectation that you'll have done certain reading assignments. And so if you go into the readings here, there'll be a link to the reading assignment directly. And we're using Perusal. So how many people have used Perusal in the class? A couple, so more, okay. So Perusal is really, and I've really enjoyed it since I've started using it in courses. So the chapters, you can download the chapters yourself as PDFs, but under these links, these read chapter links, it'll open it in Perusal. And Perusal is kind of a site where it will show you the PDF. And I have already submitted sort of comments that you can either read and kind of help highlight things that I think are important in the chapter, and you can comment on my comments, or you can submit your own comments. Like, I found this really interesting, or I disagree with what they said here, and so on and so forth. Or you can ask questions like, I didn't quite get what they were saying here. And those questions, then I can try to go by and try to answer those, if not directly in Perusal in class. And so before these special lectures that correspond to readings, and there might be one every 1.5 to 2 weeks, then you read through using Perusal. And then I've got these two things, a reading exercise and a reading assessment. They correspond to each one of these chapter things. And the way these work is that the reading exercise is an untimed assignment. You can just keep up next to your reading. And it's just asking you questions to help you sort of focus on what points of the chapter that I think are kind of important. So that it's meant to be extrinsic motivation for you to sort of hit certain things in the chapter. And then once you've done all of that, then there's a reading assessment, which is a really short assignment due before class. But you can do it the night before. And it's timed. It's usually 20 to 30 minutes time, maybe 3 or 4 questions. And in that case, it's meant to be sort of test your comprehension and retention. And so in theory, you can have the chapter open while you're doing it, but because it's timed, it's a little harder to. So once upon a time when I did these, when I taught this class, these would be paper-based assignments at the beginning of class, so it takes like 10 minutes. But then COVID happened and everything, and so everything got shifted online, and I just left them there online. So you can do them sort of as you need. So there's this kind of triplet of exercises that are associated with each one of these chapter readings. The other things I want to point out is if you go into the units at the kind of the bottom of the modules, at the top of every unit, there's an outline and a study guide. And so basically it shows everything that we're going to go over in the unit, as well as the learning objectives that I'm expecting you to get out of every unit. So if you're looking for a study guide, I come out of unit A, what was I supposed to get out of this? Like, I'm going to get a midterm coming up. What's the midterm going to test me over? Then the study guide, that will be, that's the good place to go. It'll say like for unit A, these are the things you should have felt comfortable with. For unit B, and so on and so forth. So at the top of every unit, you've got that. And then within the units, this is the ones where I've shown the kind of interdigitated again, everything together. So we've got the reading assignments, the lectures, the auxiliary materials, videos, etc. Sort of all built in sequentially inside each unit. So the way those are working. All right. So any questions on where the assignments can be found? Yeah.
So it looks like from this is not related for every class.
No, not for, so what it'll be is like, for example, today, for interesting course, a little bit about modeling. Tuesday, we're going to talk about an introduction to simulation modeling. And then Thursday, by then, you'll have read chapter 1 of Moorcroft, the textbook. And so it's sort of like you're going to compare his notes and my notes together. So it's kind of like in every unit, we'll go through a couple of things ourselves, and then we'll see Moorcroft's take on it. And we'll compare and contrast. So not every lecture corresponds to a chapter, but you could say there are groups of lectures that complement individual chapters. Any other questions? All right. Okay, so I'll get to like how things are break out in terms of percentages and grade and all that here in a second. But just basic syllabus stuff, kind of explained roughly what we're trying to do here. And the expected learning outcomes that comes out of this. When you come out of this course, I'm hoping that you'll be able to look around the world around you, find a sustainability problem, and certain sustainability problems are not going to be, well suited for simulation modeling, but some are. And so at the end of this course, it's the idea you're saying, that's an interesting problem. There's some dynamics there. My mental models aren't kind of enough for that. I'm going to need some computational help, and being able to identify those and then start putting those into a high-level language like VinSim or InsightMaker, and then actually generate a sim that is parameterized by data. So that's another thing that we're going to have to do here. It's like when you put these simulations in, you can't just make up parameters. You have to actually come up with parameters that correspond to real physical variables. So how do we do that? That's another thing that we're doing here. And then when you actually then generate these data, interpreting these data, and what do they mean about the hypotheses you came up with, and then finally using these graphs and so on to communicate ideas to someone else. That's kind of the 5 big things that I'm hoping that you'll have coming out of this course, or what you should have. If I do my job, that's what you should come out of the course. So we basically divided it up into 2 big sections here. Before the midterm, it's basically an introduction to computational modeling, introduction to numerical simulation of dynamical systems. So in units A through D, we bubble up through sim modeling, the confluence diagrams, to actual dynamical system modeling. We take a midterm over that stuff, and it's a 2-stage exam. I'll explain what that means here in a second. And then, after the midterm, between the midterm and the final, then we basically do applications. And so you're not going to learn more, you're a little bit more about modeling, but more about how to make models more complex and model real world systems. So there'll be a lot of kind of case studies for what are complex systems and have been modeled this way, and what did the tools up here tell us about those systems now. So that's the rough structure here. Like I said, the basic book here It's available for free on Canvas as well as from the library. Calc 211 or SOS 211, basically Calc 1 is kind of the big prereq, but you're not going to have to solve any differential equations in this class, just be able to recognize them. And you can find the textbook online. If you go into the units, every lecture that is associated with a chapter has been indicated. So like lecture F1, underneath it, it says read chapter 8 before lecture F1. So not every lecture has a chapter associated with it, but there are a few, and those should pop up, and they'll pop up in your to-do list in Canvas as well. VinSim is the tool that sometime soon you should probably try downloading. It's also loaded on these computers, but if you want to work it at home, recommend downloading or use Insight Maker. Insight Maker and VinSim do basically exactly the same thing. So I will demo both of them in class, and you can kind of decide which one you're more comfortable with. We all will occasionally, especially in these first couple of units, use spreadsheet software to do a little bit of the modeling for us. So Excel, Google Sheets, these will all be fine. The math one as well, and just a basic spreadsheet. So any questions about requirements? All right, so how is the grade cut up here? So basically the course is divided up, your grade is divided up into these attendance for 5%. And so I put this highlighted C syllabus for dropping policy. So we're going to find is that that there are these 4 groups of assignments here. There's actually, and I don't put them on the slides of dropping policy because for a while I was kind of deciding, converging on how many are going to be dropped. But if you look on Canvas or on the syllabus, you can see that for all 4 of these categories, your lowest certain number are going to be dropped. So so this, and if you just, if there's 5 assignments and I drop 1, and you've already done 4 and happy with the grade, you don't have to, I'm not going to judge you for not doing the other assignments. So you can feel free to take advantage of that drop policy. I guess I'm probably going to step through here. So this lecture attendance, the way this is going to work is occasionally I will give a slide that looks like this one. And I'll have probably 2, maybe 3 of these that will happen during class. And so if you're in class, or if you're connected via ASU Sync, you can go to this URL or scan that QR code, and it'll bring you to a Google form. It'll have like 10 lines on it. There'll be these answers to questions. And I will ask you a question that has to do with the lecture content. And then you'll lead that form up through the whole class. And if I ask you 2 questions, you'll do the first question on the first line, the second question on the second line. At the end of class, when I say that's the end of them, you hit submit. Then that will go in and out. If you're watching this asynchronously, you've got 24 hours to do that after I post the video. So even if you don't come to class, you can still get attendance credit by just going through and finding those simple questions. I don't grade them for correctness. I grade them for coherence and completion. So if I ask you, how many days you have to say there's a grade correct, or to get a grade correction, if you answer 7, then that makes sense. If you answer black bear, then that doesn't make sense. You won't get the. So these are just mainly meant to see, they help me see how everyone's responding to the material by seeing what sort of answers we get back there, and then they allow you to earn some credit here. But again, there's a drop policy for these attendance exercises. So, I think I drop your lowest 5 throughout the whole semester, something like that. So, there's going to be times that you can't make it. That's totally fine. You don't have to worry about that. So, attendance, you can do it asynchronously, you can do it synchronously, you can do it while you're in class. They basically will be with 2 or 3 of these things per lecture that'll pop up kind of at random times. I'll ask a question, you fill it in, you submit only at the end of the class. So any questions about that? And so then there's the muddiest point reflections. So at the end of every week, including this week, so due Sunday basically of every week, you go onto Canvas, and there will be one of these muddiest points where you'll submit in a sentence or 2 each, or even a phrase. These are really short assignments. I'll ask you a question in the Canvas assignment. What was the clearest topic covered in the week? What was the least clear or muddiest topic covered in the week? And what was the most interesting topic you'd like to learn more about? And you can answer NA for that if you all talked out and nothing really was something that you really got you really excited about. So really, you count that as NA as free credit, then I'm really just looking for a couple words here and a couple words here. We do that every week, just so I can see how people are doing. Because sometimes I'm surprised at what these two things are, the clearest and the muddiest. So now, if everything's super clear to you, instead of saying everything was totally clear to me, like nobody's point, what I actually want you to do is rank all of the things we went through in that week. And even if it's clear to you, tell me the thing that is like the least clear. So the thing you had the hardest time with, even if you understand it, the thing that it took you the longest time to understand, that's what I want you to do. Okay, those are the muddiest points. I already explained the perusal exercises. There's homework assignments. There will be a couple of homework assignments that allow us to practice our simulation modeling throughout the semester. They're individual assignments, but we will start several of them in class. So, and while they're in class, you will be able to work together on them, but I want everybody to submit their own work. So it should reflect your understanding. So if I ask you to come up with something, then I want everybody to come up with something unique. But of course, while you're coming up with it, you could do that kind of as a group to sort of brainstorm those ideas, but you have to sort of claim something that's your own when you submit these assignments. And then these exams. So I mentioned this two-stage exam, something that, anybody ever had a two-stage exam? I think that, yeah, while in college or like back in high school. Yeah, so this is something I think more common in high school, but I've had good luck with it. So the idea here of the two-stage exam, and this is both for the midterm and the final, is we're going to burn 2 lecture days for these things, but you actually can still take them remotely too. But the idea here is that your exam score is going to be split into 2 grades, 80% individual, 20% group. So what's going to happen is, let's say hypothetically, the midterm stage 1 is on Thursday. Well, what that's going to mean is you're going to have 75 minutes to do an exam on your own, the midterm, with maybe a couple of sheets of scrap paper, or scrap paper, as well as maybe some crib sheets, and it'll be totally on your own. And so I can permit people to take it remotely. I'm actually going to do this on Canvas. And so if you'd like to take them on the computers in the room here, that's fine. But I'm also going to give you a window. So like if the exam is technically on Thursday, I might open up Wednesday, Thursday, and Friday. You can start the exam any of those 3 days. But then once you start it, you'll get 75 minutes, or maybe I'll give you 90 minutes to deal with any technical issues to take stage 1. So you get through all of that. I don't give you your score. I don't give you any solutions. And so then you have a gap. And then stage 2, let's say stage 1 was on Thursday and stage 2 is on the following Tuesday. In this case, it's totally open book, open notes, and open class. So you can collaborate with each other. I will, even though both of these you'll be able to take remotely, I will be in the class at the normal class period, free to proctor. And so I basically will sit there and you can come in and you can collaborate together in this classroom, because you all have this on your schedule. Or you can do it however you like. And this too, I'll give you maybe like a 3-day window. Instead of Tuesday, it might be Monday, Tuesday, Wednesday. And there will not be time. So you just have all of those days it'll be the exact same test you took stage 1. So you won't know what you got right or wrong, but you'll be able to discuss that with each other and possibly make changes. And then once all of that's submitted, then I'll release the scores and the answers, and you will get your midterm score will be 80% times your stage 1 score plus 20% times your stage 2 score. And that's what we do for both midterm and the final. Any questions about that? Okay. And like I said, just to allow for remote as well and a lot of flexibility, I'm going to do these using Canvas. And so these will be electronically administered and graded. And then the final project. So this is a group project with some peer reviews. And so you're going to, working in groups, you're going to identify some real world system, hopefully sustainability related, and you're going to build a system dynamics model to model that system. So This, you don't really have to worry about this till basically right after the midterm. So we're going to start worrying about it kind of mid-semester. And there's a couple of smaller assignments that you'll get to sort of like propose what you're doing, tell me who's on your team, etc. That will help kind of divide up some of these points here. But the idea here, and again, I'll give more detail to this if you get close to it, is that you're not going to present to the class. What you're going to do is upload a video of your presentation to Canvas and upload your report to Canvas. And then you're going to peer review in the last week of classes. You'll upload the video and report on Wednesday, last week of class. And then every person peer reviews one video and one report. So overall, every report will get about 4 people looking at it, every video about 4 people looking at it. And then my score to reports and presentations will be an average of those plus my own effect. So you'll have the opportunity still, your work will still be viewed by other people, but as your work will still be viewed by others in the class, but we're not going to have to do the thing where we burn 1 or 2 lectures with people coming up here and presenting in front of class and everybody sees everybody else. And that helps us have time for the multiple statement. All right, so questions about the assignments, the structure. All right, so I would normally do an attendance exercise here, but I've already kind of burned enough time at the beginning here. Other things in general, once the availability closes on Canvas, then there's no late penalty or whatever. There's no late policy after that. You have to have it in before the availability window. But if you can get it in between the due date and the availability window, I usually put a gap there, a grace period, there's no penalty. Even though Canvas will mark it late, there's no penalty after that. So basically, I give you due dates to encourage you to get the work done by that time, but the availability window is sort of the real due date. And so as long as you get in before the availability window closes, as long as Canvas allows you to upload it, then for most assignments, it's fine. See syllabus for other related policies. Grade correction, I kind of hinted at this, just to prevent a mass of people asking for grade corrections at the end of the semester. Once we've scored your assignment, you've got 7 days to check on it and see if there needs to be a correction. After that, I can't discuss grade corrections because again, I don't want to set things up to where all, the 20 people would come and say like, I need to check these 6 assignments or something like that. So try to do it a week after that. And copyrighted course material, don't, any of the stuff that I give you, don't upload it anywhere else, don't sell it. Even though your own notes are technically copyright you, it's a violation of ASU's academic integrity policy for you to sell your notes. So also don't do that. I give you a bunch of past midterms, past final exams. So there's a bunch of material already on Canvas that I think should be useful samples for building conceptual models of the exams for this semester. So hopefully you don't have to turn to these third-party websites and so on. But if you do, which I shouldn't, definitely don't upload any of this stuff. If something's marked as an individual assignment, again, you can work together, but what you submit needs to be unique and reflect your own understanding. So this is sort of standard stuff for that's on the syllabus. Those who need an accommodation for a disability, contact sales, and we'll work something out. No problem. Questions? Policy stuff? Okay, so let's at least end with a little bit of flavor of intro to modeling, so that we'll be ready to go with some momentum on Tuesday. So I've already kind of mentioned a bunch of this type of thing, that these computer-based tools that we learn about in this course will help us rapidly experiment with dynamical systems models. And so instead of having to build a bunch of math and try to solve it all, we sort of write the math out and the computer does the hard work for us. But then we have to ask them, what the heck is a model? So we have to really understand what are models in order to know what to do with it. Now, these are fashion models, right? So, but why do we call them models? So if these are models, what makes them models? Why is it reasonable to use that word? Anybody have a thought?
in this case, other people done for fashion, couture, and that's how we look.
So that's interesting. So that one comment there was other people look at them for fashion, what to wear, and so on. So that is one interpretation. It was a totally fantastic interpretation. Is that one way we interpret these fashion models is they show us an option for normative ways to choose clothing. So they are modeling what a a well-dressed person dresses in. What's another way we can interpret them as fashion models? Yeah.
They represent, like, like the ideal situation for, like, in this case, a person being dressed as something. They don't have to deal with like the real world complexities of like how would that outfit actually work. Whereas in a system, you don't have to actually worry about some real world complexities to ignore some of those.
Okay, yeah, so I like that. Those are some great comments and insights here. That sort of the suggestion here is that this is sort of, if I'm understanding correctly, this is sort of an oversimplification of the fashion process. They're communicating something, but maybe they're not incorporating a lot of the real world issues that have to do with, people's, more realistic body sizes and shapes, people who don't, he probably has more product in his hair than I have in a week, they're both for some reason tilted the same way. And so there's a bunch of weird things about here. But what are the other things, any other comments on why we might call these fashion models, why we use the term model? The other thing I was kind of getting at here is, for all the imperfections here, there is a claim that this is better than looking at this jacket on a hanger. So these are not only models of what you maybe should wear, but these are models of what it might look on you if you were to put it on. So if you saw this jacket in a magazine just laying out on a table, that is probably not as informative as the jacket actually on a pair of shoulders. Now, when you look at this particular model, you might be looking at other aspects of it, other degrees of freedom that have nothing to do with that jacket. And that's something that we have to be very careful about, is that there's a garbage in, garbage out property of models. And that the function of fashion models, at least initially, was to model the fashion, to say, you want to know what it looks like to wear a jacket like this? Well, you'll have the jacket, but I'll put it on somebody else who is a human, and maybe that human will end up being closer to what you look like than a hanger or a table. And but because there's these extra degrees of freedom, then even though it might look good on this model, when you put it on you realize this doesn't fit. So, otherwise, like my biologist friends would refer to this as an animal model. So this is a laboratory mouse. So in this particular case, the example here is that you could put this through experiments. You could say, well, let's deprive it of sleep and see how well it solves problems. There might be a pharmaceutical trial. There might be a bunch of different things that you would subject to this animal as a stand-in for the system you actually care about, which would be like a human system, for example. Now, this mouse is far from a human. It has a tail, for example. It's got a lot more fur than your average human, but it is still a mammal. It has a lot of the same vertebrate physiology as a human. So it's a lot better than an ant, for example. It's a lot better than a plant. So the physiology is a lot closer, but we don't necessarily have confidence that the result we get with this model will definitely work on a human. But if it causes problems in this model, it gives us a hint that maybe it'll cause problems in the human model. So that's kind of an example there. Likewise, this is a sort of Bohr model of an atom. So kind of looks like a solar system. Turns out that later on, Bohr recognized that this model wasn't great at making really fine scale predictions. So he turned it into a more realistic kind of solar system model with these elliptic orbits of electrons around a nucleus. And that maybe got a little bit better. But then Far later than that, you've got things that you see in a freshman chemistry course like molecular orbital bond theory, which is a totally different way of modeling electrons around a nucleus. And then you've got the kind of nuclear physics of the standard model of what goes on inside the nucleus, and that also involves an electron. And in all of these things, we see perspectives on an electron changing over time. But the key message here is that really electrons are not being claimed. We're not claiming electrons exist. We're just claiming that a mathematical model that has electrons in them is useful. And so there might be an enterprising young physics graduate student a couple blocks down the road from here who's coming up with a new model of how matter works at the finest scale that doesn't have electrons in it. And once she discovers that, shows that it solves some problem with discrepancies between these models and reality, then it might be that children from that point on, and starting in primary school, stop learning about the electron. So it's like the electron ceased to exist in an instant. But in the early, we're not ever searching, we're not ever trying to build models to reflect reality. We're just trying to build models that help us do useful things. And so, you know, I kind of running behind on time here. So the other sort of example of this is Newtonian gravity is very different than relativistic gravity. Newton was totally wrong about gravity, and yet Newtonian gravity, you know, keeps planes in the air. Like Newtonian physics, Newtonian mechanics are super useful, and it's really hard to use relativistic dynamics for most of the engineering problems that we deal with out here on Earth. So it's not about being realistic; it's about being useful. And so what I kind of want to get to here, so I'm just going to kind of like, I won't rehash some of this stuff next time, is that my definition of a model, the thing that I'm hoping that you'll take away here, is that models generically are anything that provides an answer to a what-if question. And so, and that could be a graph you draw on a wall, that could be a figure you make with your hands, that could be a verbal model, it could be something in your head. It doesn't have to be a piece of math, doesn't have to be a computer. It could be something you assemble. It could be a physical model. You could say this is a model of a volcano, and it could be something with baking soda or something like that. It has nothing to do with plate tectonics, but it helps you answer a certain what-if question. So anything that helps you answer that is what we call a model. They're fashion models because they help me answer the question, what if I was to put that jacket? All right, so that's kind of the key point that I want to get to today. I don't want to keep you guys any longer after that whole disaster, which I'm going to try not to have happen on Tuesday. Moving forward, complete that Unit 0 activity by Sunday. Start reading Chapter 1. I'm going to fix all the due dates so that you won't have any trouble with that. And it's a good idea to maybe start looking into downloading VinSim or creating an account on InsightBase. And that's all I've got for you today. So again, sorry for the slow start. Have a good weekend. Try to stay dry.